Problem number 23 says to write the inverse function for this. So the first thing I'm going to do in any inverse problem is switch the x and the y. So the x is now y, the y is now x, and now we're going to solve this for 1. I'm sorry, if we're going to solve this for y. So I subtract 1 on both sides. So x minus 1 equals sine of 4y. Now to get rid of the sign, I'm going to do arc sine x minus 1 equals 4y. And then I'm going to divide both sides by 4. So in a multiple choice situation, the answer is either going to be sine inverse of x minus 1 over 4, or it's going to be 1/4 sine negative 1 of x minus 1. With the x minus 1 in parentheses no matter what. Okay, we're going to verify this. We got cotangent squared plus sine theta times 1 over sine theta. And so in this particular part of the problem, because cosecant changed to be 1 over sine theta, I'm going to cancel out the sine thetas. So cosecant squared theta equals cotangent squared theta plus 1. And since cotangent squared theta plus 1 in our Pythagorean identities is cosecant theta, we have just verified the identity. Remember, all of these are from 7.1, 7.2, and 7.4 sections. Alright, for this particular problem, since I'm really not sure what to do, it's best to change everything into sines and cosines. Now at this point, I'm going to get a common denominator, which means that the common denominator here is cosine A. So this term needs a cosine A over cosine A. So it becomes 1 over cosine A. And since that's the common denominator, it's actually underneath the whole thing. And cosine times cosine is cosine squared. On the opposite side, I have sine times sine, which is sine squared A over cosine squared A. Now if you remember, we had the equation sine squared plus cosine squared equals 1. And if I subtract cosine on both sides, sine squared theta equals 1 minus cosine squared theta, which means this can go right in here for 1 minus cosine squared A. So that means I have sine squared A over cosine A equals sine squared A over cosine A. Not exactly sure where that squared came from. It shouldn't have been there. And so since both sides match, that's going to be my answer. We got cosine squared x minus sine squared x. And if you look back at your notes from 7-4, if I want to rewrite this as one function, this is the same thing as cosine of 2x. Alright, for this one we're going to need to cross multiply. So that's going to go up there, and that's going to go up there. And so I got 1 plus sine theta plus 1 minus sine theta divided by, when I multiply these together, I got 1 minus sine theta times 1 plus sine theta. In the top, the sine thetas cancel, and 1 plus 1 is 2. On the bottom, if we FOIL, or distribute twice, the middle terms are going to cancel out, so we get 1 minus sine squared theta. Now if we go back to this problem, where we had sine squared equals 1 minus cosine squared, we could also have done this the opposite way and figured out that cosine squared is equal to 1 minus sine squared theta, if I would have subtracted sine squared instead of cosine squared. So this turns out to equal 2 over cosine squared theta, and the reciprocal of cosine is secant, so this is 2 secant squared theta. Alright, last one for this particular video in problem number 29. And what I'm going to do over here is I'm going to separate the top part, because I don't want a whole lot of time trying to figure out flipping the tangent, and we'd have fractions inside of fractions, so we just split up the top. 1 over tangent squared is the same thing as cotangent squared. Tangent squared divided by tangent squared is 1, equals cosecant squared theta. Cotangent squared plus 1 is one of those Pythagorean triples, or Pythagorean identities, that turns out to be the same thing as cosecant squared. And therefore we get cosecant squared equals cosecant squared.